Hi, and welcome to my projectile motion analysis project by Laura Diaz. Okay, let's begin. First up is our video of reference, and this stars Adrian Pacini. Thank you for starring in my video. And what it is, it's basically Adrian walking across a bricked wall. Now, each brick is 16 inches long, so that's the scale I used for all of my graph. While walking in the video, Adrian starts off at a constant speed and eventually slows down, while the camera remains at a still angle. This brings us to our motion diagram. Like I said before, his acceleration slows down as the video goes on, but his velocity remains the same. He is also walking towards the right, and that's why our velocity is facing the right. Continuing, we come upon our position versus time graph. So first up is our x. Now, as you can see, our x component increases at a constant rate. Now, if we go to the y decreases, and then it goes to a fairly constant rate. Now this brings us upon our position versus time graphs, and now these are basically both graphs put together just so we can compare the two. As you can see, the x component increases while the y component decreases and then remains constant, which then brings us to our position versus time table. And in it, you can see the x component increasing and the y component starting out at a 21.4 and then decreasing to a constant 21.1. This shows us that our x component goes up in a positive x direction, while our y component at first decreases, then continues towards a constant motion. Next up is our x velocity versus time graph. You can see the velocity increasing, but then decreasing at the very end, and this is because Adrian slows down at the end of the video. Now, while looking at our y velocity versus time graph, you can see that it is going up in a positive direction, with velocity increasing. Continuing on is the comparison of the two graphs. Now, you can see the y velocity at a negative and fairly constant rate, while the x velocity sits around the 20-ish range of inches per second and goes into a bit of a parabolic form. You can see that the two graphs differ greatly because the y velocity is fairly constant and the x velocity is more shaped. Moving on to the table, we can see the numbers more clearly. Now, our x component is increasing, but at the very end it decreases by 0.5. Whereas the y component is negative, and it seems to be decreasing. Okay, moving on is the acceleration versus time graph. So first we have our x component, and as you can see, it is decreasing quite obviously. It is going in a negative direction. And this is because Adrian slows down at the end of the video. Now comes our y component, and you can see this graph is a little bit more shaped. Now you start off somewhere right above 0.1, and then you go up, so positive direction, and then it just goes negative from there. So unlike our velocity versus time graph where it went positive then negative, here in our acceleration versus time graph it went negative to positive, or rather it just remained positive. Moving on in the comparison of the two graphs, you can see that the x acceleration decreases while the y acceleration stays fairly constant, where they both meet somewhat in the same area at the very end of the graph. this brings us to our table, and it's a clear depiction that on the x acceleration, it decreases drastically, whereas in the y acceleration, the increase and decrease range is actually quite small. It just depends on the tenth. So it would be safe to assume that our y acceleration could be perceived as fairly constant because it's separated by such a small ratio. And that is all for my projectile motion analysis project. Thank you so much for listening, and I hope you have a great day. Thank you.